Alright, hello again. We are working on the Algebra 1A exam review packet. This is Ms. Israel coming at you from Einstein High School. And we are going to look at Unit 1, Topic 1, Number 6. Now this question is pretty long, and you notice I'm using a flip chart, so I'm going to answer each letter A through F on separate pages of our flip chart. Okay, so work with me as we do this. I'm going to read the question. A food truck sells 3 items: hot dogs, sodas, and fries. In order to make a spreadsheet, the food truck owner needs to define some variable. So we have a table here. We have the symbols in our left column and the meaning for each of those symbols in our right column. Now, one thing we need to make note of is that this question is going to use subscripts. So a subscript is just the little number or letter here. Okay, in this case, that's going to stand for price in dollars charged for 1 hot dog. So let's look through our list of symbols down here. We have H, the number of hot dogs sold in a day. S, the number of sodas sold in a day. F, the number of orders of fries sold in a day. We have P sub H, which is the price in dollars charged for 1 hot dog. P sub S, which is the price in dollars charged for 1 soda. P sub F, which is the price in dollars charged for 1 order of fries. And finally, we have C, which stands for the total number of customers. So those variables are going to represent these quantities: hot dogs sold, prices in dollars, total number of customers. Let's look at question A. Write an inequality for the following statement. The number of hot dogs sold in a day was at least 400. So I have a few things that I would like us to circle. The first thing I'm going to circle or box here is the number of hot dogs. I recognize that from our table. Here it is, the number of hot dogs sold in a day. And we know that we are going to use the variable H to represent the number of hot dogs. So let's go ahead and write an H there. The next thing I see was this term at least. We have an inequality statement being made. At least is another expression for greater than or equal to. So I'm going to go ahead and label that with our symbol for greater than or equal to. And finally, we have our numerical value 400. When we put that together, we get the expression H, the number of hot dogs sold, was at least 400. And that is our answer for A. Moving on, let's look at B. Part B. What does the inequality S times P sub S is greater than or equal to 1,000 mean? We really need to think about what's going on here. So what I notice is we have the number of hot dogs sold times the price of each soda. Excuse me, I think I made a mistake back there. Let me change that to soda, the number of sodas sold. And we know that that's going to be greater than or equal to 1,000. So what's really going on here? The number of sodas sold times the price of each soda. Let's think of that in a real world context. And I just want you to listen here while I give us some examples. So let's say I sold 100 sodas and I multiply it times the price of each soda. Let's say each soda is $2. What value have I got here? I end up with 100 times $2 for a total of $200, which is going to represent the total price for 100 sodas. So that's really what we have on the left side of our equation. S times P sub S represents the total price of S, or some number of sodas. Okay? So let's put that into a complete sentence. I'm going to scroll down a little bit. And this is where you can actually write. We're going to say the total price of S sodas is greater than or equal to $1,000. All right, moving on, let's look at letter C. Write an expression for the total number of hot dogs, sodas, and order of fries sold in a day. So we need an expression. An expression is going to be a combination of variables or symbols in this problem and some operations: addition, subtraction, multiplication, or division. So we want an expression for the total number of hot dogs, sodas, and orders of fries. Notice there's no reference to price. So the only symbols we're going to be using for this question are H, S, and F. All right, we know that hot dogs, the total number of hot dogs is H. We know that the total number of sodas is S. And the total number of fries is F. Okay, so the total number, in this case, total, is going to refer to addition. So I know that I'm going to have the number of hot dogs plus the number of sodas plus the number of French fries. And that is our expression for the total number of hot dogs, sodas, and order of fries sold in a day. All right, let's move on to letter D. Write an expression for the average number of sodas sold per customers in a day. Okay, so let's review what's average. When we find the average, we usually calculate a total amount and then divide by how many? All right, so we need the average number of sodas sold per customer in a day. In this case, we know the total number of sodas sold in a day is going to be S, and we know that how many customers there are is represented by C, and there's our expression for the average number of sodas in a day. Moving on to letter E. Switch up my color here. On a recent day, less than $2,000 was made selling hot dogs and fries. Write an inequality for this statement. Okay, we have a lot to think about in this problem. We're dealing with money, less than 2,000. That's going to be less than 2,000. We have the less than symbol. Selling hot dogs and fries. So we have to think back up to letter A. In order to deal with money, we have to know how many of each type of item we sold. So in order to find the price of hot dogs sold, we're going to need to multiply H times piece of H. That represents the total number of hot dogs times the price of each hot dog. In addition to that, we need the total price of the fries. So we need how many fries we sold, F times the price for each order of fries. And we know that we need to have our expression be less than $2,000. And that's going to be our inequality. Moving on to letter F. Okay. On another day, the food truck sold a total of 1,500 hot dogs, fries, and sodas. There were 700 hot dogs sold. The number of sodas sold was 3 times the number of order of fries. Determine how many orders of fries were sold. All right, we have a lot of information going on in this problem. First, we know that we sold a total of 1,500 hot dogs, fries, and sodas. Let me circle the whole thing. We know there was 700 hot dogs sold. We also know that the number of sodas sold was 3 times the number of order of fries. And we want to know how many fries were sold. The first thing I like to do is define my variables. So I'm going to go ahead and list each of my variables. H, S, and F. And when I say define, I want to actually come up with values or variables that represent each of those symbols. So we know hot dogs is 700. Why? Well, right here, there were 700 hot dogs sold. We know the number of sodas sold was 3 times the number of fries. I can write an expression for that. 3 times F, or 3F. And finally, we don't really know anything else about the fries. We just know that they're there. They're fries, and that's what we're solving for. The next thing I need to do is write an equation. So let's go back and read that again. We know that the food truck sold a total of 1,500 hot dogs, fries, and sodas. I'm going to write an equation for that. I know that total, meaning addition, the number of hot dogs, plus the number of sodas, plus the number of fries equals 1,500. The problem we have is there are too many variables. So we're going to go back to our list and replace as many of these variables as we can so that we end up with just one variable on our equation. And remember, the question was the number of fries sold. So let's see if we can get only F's in our equation. Start with H. Well, we know that H is 700. So let's replace or substitute that H value with 700. We know that the number of sodas was 3 times the number of fries. So instead of S, I'm going to write 3F. And again, we don't know much about the fries, so we're just going to leave that F alone. And we know that this is equal to 1,500. And what you'll notice is we have one variable now. It makes it a lot easier for us to solve. Okay, I'm going to read that equation again. 700 plus 3F plus F equals 1,500. I hope you notice that we have some like terms on the left side of our equation. We have a positive 3F and a positive 1F for a total of 4 F's. Let's bring everything down. 700 plus 4F equals 1,500. And now we're left with a two-step equation. Those aren't so bad. We've done a lot of those this school year. Let's see if we can't solve for F. All right, first thing we're going to need to do is use the subtraction property of equality, and we're going to subtract 700 from each side of our equation. What I'm left with is 4F is equal to 800. I have a one-step equation now. 4F equals 800. In order to get rid of the 4, I'm going to use the division property of equality and divide both sides by 4. And what I'm left with here is F is equal to 200. Because this is a word problem, I like to answer in words, so I'm going to add a sentence here. And I'm going to say the number of French fries sold was 200. And there's a lot of ways that we could have said that. We could have said there were 200 French fries sold that day, and so on. That completes problem number 6, and I hope you'll join me for our next video.